Welcome to Understand the Math. In this problem, we're given a matrix A and a transformation T defined by T of X is equal to A times X. And this is a linear transformation because it's T of X is written as A times X. We're asked to determine if T is 1-to-1 and or onto. Before we go into the mechanics of what to do, let's talk a little bit about what does it mean for a transformation to be 1-to-1 and a transformation to be onto. A transformation is 1-to-1 if each T of X is the image of 1x. This just means that every T of X is unique. We can think of this as thinking as T of x1 cannot be equal to T of x2. Okay, so each transformation is the image of 1x, so we can't have two transformations that are the same. The way that we can determine this by looking at a matrix is a transformation will be 1-to-1 if every column of A has a pivot. Now let's look at a onto transformation. When we have an onto transformation, each T of X is the image of some X. This means that every T of X will have an X associated with it. This will happen when every row of A has a pivot. So when we're checking to see if T is 1-to-1, we have to look at a column of A. And if we're checking if T is onto, we have to look at a row of A. What we're going to do is we're going to take A and we're going to put it in echelon form, and then we're going to see if each column and row has a pivot. Let's begin by writing down our matrix A, 2, 1, minus 6, 3, 7, 4, and we're going to put this in echelon forms. I'm going to begin by circling our pivot. I think it would be a lot easier to start if we went ahead and scaled row 1 to get a 1 in the upper left. So I'm going to say that row 1 is row 1 divided by 2. So we're going to take row 1 and every entry is going to get divided by 2. That'll make the row reduction a lot easier. Now let's go ahead and circle that pivot again, and we're going to get a 0 below that pivot. And now we can avoid some fractions. So we're going to say that row 2 becomes row 2 minus 3 times row 1. So we have row 1 stays the same. And then row 2 is going to be a 0. And then in this entry, we're going to have a 7 minus 3 halves. So what is that? A 14 minus 3 over 2, which gives us an 11 halves. So we'll squish in 11 halves. And then in this next entry, we're going to have a minus 9 plus 4, which gives us a 13. Good thing to do is to circle the pivots, since we're looking to see which row and which columns have pivots. Let's first look at 1-to-1. So if we're looking at a 1-to-1 transformation, every column has to have a pivot. Notice that our third column does not have a pivot. So we have to conclude that our transformation is not 1-to-1. And the reason for that is that we have a column without a pivot. Now let's look at our onto transformation. You can see that every row has a pivot. So that tells us that our transformation is onto. So we're going to say that T is onto. And our reasoning would be that every row has a pivot. I think the key to this problem is just remembering that you're going to start with your matrix A and you have to put it in echelon form and then look at the pivots in each row and each column.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.